Okay, just going to start going through the questions that I assigned for homework today. So I'm going to start with the textbook stuff, then we'll go to the handouts. So for those of you following along, we're going to cover page 91. And I'm going to start with question 2. And then after solving that, I'll go ahead and solve question 4. So let's actually start with question 2a. Now, if you're reading along, the question says, Speary travels from Edmonton to Grand Prairie. On the map, the distance is 9.1 centimeters. So let's actually write down what that tells us. So 9.1 centimeters is actually the map distance. Okay. It says the scale is 1 to 5 million. So let's write that down. So now I've got the map distance and the scale. Now part A says, what is the actual distance between the two cities? And that's actually what I want to try and find. So this is a situation where writing fractions will actually help us out. So let's actually solve that. Let's put map over actual. So the question tells us the map distance is 9.1. Okay. And then the actual distance, well, I don't know, so let's use x as the variable. And the scale tells me that it's 1 to 5 million. Now, since it makes sense that the map is smaller, I'm going to put 1 as the map, and then 5 million as the actual distance. Now I've set up the fractions, so what I want to do is, let's use a different color here. Actually, I'll get the same color. I want to go from known to unknown, so this direction, to this direction. Okay, so to go from known to unknown, I already know already, from 1 to 9.1, I'm going to multiply by 9.1. So what I do to the top, I also do to the bottom, so 9.1. So when I actually grab my calculator, do 5 million times 9.1, we do that times 9.1, that gives me this number. So x is equal to 4. There's 5, 1, 2, 3, 4, 5. So that works out to 45,500,000. Now what should the units be here? Now up here we established that 9.1 is in centimeters. So since this is in centimeters, x also must be measured in centimeters because that's what 9.1 is. If you want a more precise answer, okay, to turn centimeters into kilometers, I basically chop off 3 zeros to turn into meters, then 2 zeros to turn into kilometers. So this is actually the same as 455 kilometers. Okay? And just like for the quiz, if you want to bring in a conversion sheet to change from centimeters to kilometers, that is totally fine. Okay, so if you want to write it more clearly, the map distance or the actual distance is 455 kilometers, and that's the answer for part A. Now let's go ahead to part B. B says Speary's car uses 1 liter of gas to travel 7.5 kilometers. So let's write that. So 1 liter for 7.5 kilometers. At this rate, how much gas will she need for the trip? Well, there's a variety of ways you can solve this, but let's use fractions here. So let's actually let's put, let me see, gas over distance. So let's kind of write these as fractions. So 1 liter of gas for 7.5 kilometers. Now I want to know how much gas there is. Let's use Y for 455 kilometers. Okay, the units at the bottom are consistent. They're both kilometers, so that works. So I'm going to go from known to unknown, known to unknown. So I don't know what I have to multiply 7.5 by to get 455. But what I can do is do that division. So 455 divided by 7.5, that gives me 60.6 repeater. So to divide, I go this way, divide by 60.6, that means to go forwards, I'm multiplying by 60.6 repeater, so I'm multiplying by 60.6 repeater. Well, to solve for y, simply get y is equal to, if I round this to, let's just round it to actually let's just round it to the nearest liters. I'll get 61 liters because I'm multiplying 1 by 60.6. Okay, and then as always, I'd put my statements and my answer, 61 liters. Now let's get to part C. So part C says Spiri estimates that her average speed will be 70 kilometers per hour. How long will it take her to complete the trip? Now again, there's a variety of ways you can solve this, but if I want to stick with the fraction methods, let's try this. Let's try distance over time. Okay, how do I get that? Well, she travels 70 kilometers over every 1 hour. That's 70 kilometers per hour, right? The per hour is the same as writing a fraction. So let's set up this fraction. Now what distance, how long will it take us to complete the trip? Well, I know the distance. The distance for my original part A is 455 kilometers. I want to know the time, so let's call this B. Okay, so again, known to unknown, known to unknown. So 7 to 455, let's do the opposite. 455 divided by 70. Sorry, I said 7, it should be 70. That gives me 6.5. So I'm multiplying by 6.5 to get 455. So I'm also multiplying by 6.5 to get B. And if I do that, and what B is, whoops, mistake, 6.5 hours. And I put my statements, therefore it would take 6.5 hours for her to complete the trip. Okay. And now let's solve the last one, D. It says, what if Spiri's average speed was 10 kilometers per hour greater? How much time would she save? Okay. Now, again, it's distance over time. It says, what if it was 10 kilometers per hour greater? So if it was 70 originally, well, 10 kilometers per hour greater would be 80, still over 1, because it's still kilometers per hour, or kilometers per 1 hour. Okay? And she's traveling the same distance, so it's still 455 kilometers. Okay? And I got that from over here, my original distance. And now I want to find, let's call this E. Okay? So, known to unknown, known to unknown. Let's try and figure this out. 455 divided by 80. That gives me 5.6875. So times 5.6875. So E is equal to 5.6875. Now that isn't my final answer, because the question asks, how much time will she save? So the time she'll save is actually 6.5, which I got from part C up here, minus 5.6875, which I got from here. And I want to find the time savings. So let's do that. 6.5 minus 5.6875, which equals 0.8125 hours. And I would accept this answer here, okay? But I'm guessing the textbook is probably converted to minutes. So if it's 0.8125 hours, to convert that to minutes, all I'm doing is 8125 times 60, because there's 60 minutes per hour. I end up with about, if I write it to nearest minute, it's about 49 minutes, and that's minutes saved. Okay, and then I put my statements and then write that out. Therefore, if you travel 10 kilometers per hour faster, you'd save 49 minutes, and that's rounded to the nearest number of minutes. Okay, now I'm kind of running out of space for that, so let's actually go ahead and solve question 4 in the little bit of space that remains here, because question 4 is actually much shorter. And if you're following along, the textbook says, the grade 8 class at Wheatley Middle School sold 77 boxes of almond chocolates. This is 22% of all the boxes of chocolates sold. So the question tells you that 77 boxes equals or is 22%. Part A says estimate the number of boxes sold. So if you want to do that, well, I can kind of think to myself, well, 22% is really similar to 20%. Okay? And I know that 20% times 5 gives me 100%. So I could take, well, 77 times 5, or if I want to kind of estimate more accurate, I could even just go with 80 instead of 77 times 5, and that gives me about 400 boxes. Okay. So that's how I would do some estimation. I'm actually making this conversion. 22 is similar to 20, and 20 fits into 105 times. I could think 77 times 5, but really, it's hard to do in my head, so let's just turn that 77 into 80, and just do 80 times 5, so that's about 400 boxes. So that's if I'm estimating. But if I'm actually calculating, well, let's do that using the fraction methods. Okay. So 22% is the part, 100% is the whole. How many boxes is the 22%? Well, that's 77 boxes as the parts. And I'm going to find the number of wholes. So again, you go known to unknown, known to unknown. And I'm just going to leave you to solve the rest of it. And if you solve for x using this method, you will get the correct answer. Okay? So I'm going to end this video here, and I'm going to go ahead and give you guys a quick break, and I'm going to post the second video for the handouts.